Hello, my name is Kushal Basin, and I'm excited to present my solution for Atlan Observability Internship Challenge. This challenge tasks us with improving the debugging experience for engineering teams, focusing on scenario with the problematic API release. The core issue was the REST API endpoint suffering from high response time and error rates. Existing logs were inadequate and debugging was slow, manual, and reliant on a few senior engineers. The efficiency impact, development velocity, and incident resolution time. My approach centers on providing comprehensive observability to empower all engineers to quickly identify, diagnose, and resolve such issues. To address this, I designed the following system. The diagram illustrates the flow of data and the key components involved. Here is a breakdown of the system as shown in the diagram. Front end. The user application interacts with our API. The gateway. This component acts as a single entry point for all the requests, routing them to appropriate service. API endpoint. This is a specific REST API endpoint we are monitoring for performance issues. As the diagram shows, this API endpoint interacts with several systems. The database. The API endpoint retrieve and interact database to store data. External API. This API endpoint also communicates with an external API. Monitoring system. Here, the monitoring system is Grafana that collect and display metrics from API endpoint and provide insights to its performance. Logging system. Here, the logging system is Loki, which gather and stores data and logs from API endpoint, capturing detailed information about its operation. Tracing system. The system tracks requests as they travel through the API endpoint and its interaction with the other services, enabling end-to-end visibility. In this design, the API endpoint is central and I have instrumented it to send metrics to monitoring system, logs to logging systems, and traces to tracing systems. The telemetry data is then used to gain a deep understanding of the API endpoint's behavior. This architecture allows us to isolate performance bottlenecks, identify the root cause of errors, and gain a holistic view of the system's health. Metrics and logging. A crucial part of observability is selecting the right metrics. I have focused on comprehensive set of metrics to provide a detailed view of API performance and resource utilization. This includes performance metrics, P99, P95 latency to understand tail latency distribution, ensuring that even the slowest requests are within the acceptable bounds. Requests per second to measure the API throughput and identify the traffic patterns. Active requests and handlers to monitor concurrency and identify potential bottlenecks in the request processing. Resource utilization metrics, CPU utilization to track the CPU usage and identify the potential overload. Memory utilization to monitor memory consumption and prevent out of memory errors. Disk utilization to track disk usage and identify potential disk bottlenecks. We have some system metrics, open file descriptors to monitor the number of open file descriptors which indicate resource leak or system limits. Node.js external memory to monitor memory used by Node.js external resources, example buffers, native components. Garbage collection to track frequency of garbage collection which can impact the performance. For logging, I have implemented the logging using JSON format. This ensures that logging are machine readable and easily searchable. Now let's look at the dashboard I designed. The dashboard provides a central view of API health and performance. Here are some key sections. First is latency distribution. This graph shows P99 and P95 latency over the time, highlighting any performance degradation or outliers. Resource utilization. The panel displays CPU utilization, memory, and disk utilization, allowing for quick identification of resources bottlenecks. This graph shows the number of active requests and handlers help to understand API load and capacity. Node.js runtime. This section visualizes the Node.js specific metrics like garbage collection, count external memory usage, and provide insight into runtime environment health. System metrics. This section shows the open file descriptors. We have the information logs that shows detailed logs of all the systems in the high level diagram. The dashboard include interactive features like range selection, filtering endpoint, zooming, etc. These features allow engineers to drill down into specific area of interest and quickly isolate the problem. Alerting is configured to notify engineers via email when critical thresholds are breached, enabling proactive issues resolution. For example, alert can be set for high P99 latency, high CPU utilization, or excessive garbage collection. Let us see how the solution is valid or how the problem is solved. My solution directly addresses the scenario's problem in several ways. First is reduce debugging time. By providing a centralized and intuitive dashboard with correlated data, engineer can quickly pinpoint the root cause of issues, reducing mean time to resolution. The detailed metrics including latency percentile, resource utilization allow for precise diagnostic. Improved accuracy. The use of structured logging and distributed tracing ensures that all the relevant information is captured, leading to more accurate diagnosis. Reduce reliance on experts. The dashboard empower all the engineers to monitor and troubleshoot the API, reducing the dependency on a few experienced individuals. Proactive issue detection. Automated alerting enables engineers to identify and resolve issues before they significantly impact. For instance, alert on high P99 latency can prevent user-facing performance problems. For future improvements, I would develop tools to automatically generate dashboard for new API endpoints, reducing manual effort and ensuring consistency. Implement predictive analysis using machine learning to predict the potential issues before they occur, enabling proactive intervention. For example, predicting high resource utilization based on traffic patterns. Enhanced traceability for further improved distributed tracing to provide even more granular insight into request flow. To prevent similar issues from reoccurring, I recommend code reviews, continuous monitoring, post-mortem analysis, documentation, and comprehensive testing. In conclusion, In conclusion, my solution provides a robust and scalable observability system that will significantly improve the debugging experience for Atlan engineers by providing the right data at the right time. The system will enable faster issue resolution, improved API reliability, and increased engineering productivity. Thank you for your time.